This is a video from the Exam 3 review. The directions say to find the local and absolute extreme values on the given interval. So let's take a look at problem number 1. Suppose f of x is equal to x cubed minus 9x squared plus 24x minus 2. And the interval is the closed interval 0 to 5. First step, take the derivative. F prime of x is 3x squared minus 18x plus 24, which is equal to 3 times x squared minus 6x plus 8. And we can go one step further and say this is 3 times x minus 2 times x minus 4. So we're going to set f prime of x equal to 0. And so 3 times x minus 2 times x minus 4 equals 0. So x is 2, or x equals 4. Now, from here, we can set up intervals. And our intervals will be from 0 to 2. We're going to go from 2 to 4. And we're going to go from 4 to 5, like so. Now, what do we want to test? On the interval 0 to 2, I'll test x equals 1. On the interval from 2 to 4, I'll test x equals 3. And then on the interval from 4 to 5, I'll test x equals 4.5. And we're going to determine on 0 to 2 whether the function's increasing or decreasing. Same with 2 to 4 and 4 to 5. So over here, I'm going to put increasing or decreasing, like so. Okay. So on the interval from 0 to 2, I'm going to test x equal 1. And I'm going to evaluate f prime of 1. Well, f prime of 1, again, I'm going to plug it into the derivative here. And if I replace x with 1, I get 3 times negative 1, which is negative 3. Negative 3 times negative 3 is positive 9. So this is 9, but really what I want is that it's positive. And so it's increasing on that interval. If I plug in 3, well, if I replace x with 3, I get 3 times 1, which is 3. And then 3 times negative 1, which is negative 3. And that's less than 0. That's decreasing. And if I plug in 4.5 into the derivative, I claim you're going to get a positive value. And so on the interval 4 to 5, it's increasing. Okay, so what does that mean? Now, if you go from increasing to decreasing, we have a max. If we go from decreasing to increasing, we have a min. So f has a local. Now let's see, we're going from increasing to decreasing. So f has a local maximum at x equal 2. F has a local minimum at x equal 4. Now let's take a note here. Let's remind ourselves, f of x equals x cubed minus 9x squared plus 24x minus 2. Okay? Now, f of 2 is 8 minus 36 plus 48 minus 2. And that's equal to negative 28 plus 48 minus 2, which is 18. F of 4 is 64 minus, and then what's 9 times 16, right? So we'll just say 9 times 16 plus 96 minus 2. And then if you plug that into the calculator, um, 9 times 16 is 144, right? And I'm going to take negative 144, add 64, and then I'm going to add 94. And then this is 14. So f has a local maximum at f of 2 equals 18, and a minimum at f of 4 equal 14. But now, to find the absolute max and min, what do? Well, we need to figure out f of 0. Okay? Now, f of 0 is going to be negative 2. And then let's remind ourselves, f of 2 is 18. F of 4 is 14, right? And then f of 5 is 5 cubed minus 9 times 25 plus 24 times 5 minus 2. And so this is 125 minus 225 plus 120 minus 2. So this is negative 100 plus 120 minus 2, which is 18. So what does that mean? Notice, f has an absolute maximum at, and then we're going to say f of 2 equals 18, and f of 5 equals 18. F has and absolute minimum at f of 0 equals negative 2. Because notice, if we go back, this is the smallest y value. And then here, and, if we take f of 5 equals 18, these are the largest y values. So, and that's how you do problem number 1. Let's take a look at problem number 3. So on problem 3, we have f of x equals x plus 2 cosine x. And the interval is negative pi to pi. So trigonometry is very fair game. So I'm going to take the derivative of f and get 1 minus 2 sine x, right? Just like before, I'm going to set f prime of x equal to 0. So 1 minus 2 sine x equals 0. So 2 sine x equals 1. So sine x equals 1/2. Now remember, you're on the interval from negative pi to pi. Okay? So where is that pictorially? So here's y. Here's x. Okay? Now, remember that sine of x equals 1/2. Well, so we know that x can be pi over 6. That's right here, right? But we also know that we can be over here, right? And so we can also get 5 pi over 6. That's fair game, right? But the question is, can we be down here or over here? And I would say the answer is no, because remember that our restriction is from negative pi to pi. And if I plug in an angle in the third or fourth quadrant, you're not going to get, you're going to get a negative y value, if that makes sense. And so we have an interval, okay, and we have a test, and we're going to go increasing, decreasing. And so I'm going to go from negative pi to pi over 6, pi over 6 to 5 pi over 6, and then 5 pi over 6 to pi. And let's remind ourselves, f prime of x is 1 minus 2 sine x. So here I'm going to test x equals 0. And then from pi over 6 to 5 pi over 6, we can test x equal pi over 3. And then from 5 pi over 6 to pi, well, think of pi as 6 pi over 6. And the easiest way to go is to go in the middle. So we can try 11 pi over 12. Now, f prime of 0, what I care about is that that's positive because sine of 0 is 0. And so it's increasing on the interval negative pi to pi over 6. And then if I plug in pi over 3, f prime of pi over 3 turns out to be negative. And so it's decreasing on this interval. And then if I plug in 11 pi over 12, I claim that's going to be positive, and so it's increasing. Now, what does that mean? Well, let's remind ourselves. F of x is equal to, it's x plus 2 cosine x, right? And so f has a local. Now, increasing to decreasing, so it looks like a local max. At f of pi over 6, which is pi over 6 plus square root of 3. F has a local min at f of 5 pi over 6, which is 5 pi over 6 minus square root of 3. Okay? Now, if I take f of pi, I'm going to plug x, replace x with pi. You get pi plus 2 cosine pi, which is pi minus 2. This is approximately 1.14, okay? And then f of negative pi is negative pi plus 2 cosine of negative pi, which is 2 minus pi, which is approximately negative 1.14. And then the question becomes, which one's the smallest y value? Now, and which one's the biggest y value? So, if I take pi over 6, and then I add square root of 3. So this is about 2.26. And then if I take pi over 6, and then multiply by 5 and subtract square root of 3, this is about 0.89. Okay? And so what does that mean? That means f has an absolute maximum at, now, the biggest y value appears at pi over 6. So it's going to be f of pi over 6, which is pi over 6 plus square root of 3. And then f has an absolute minimum at, and then it's f of negative pi equals 2 minus pi. And that's how you do problem 3. And then that's a good stopping point for this video. This is a video from the Exam 3 review, and we looked at problems 1 and 3. Thank you.